Hello all, welcome back, and again it's an episode on biochemistry, or you can say bioinformatics itself, because that's my area of PhD. So we'll be looking at visualizing molecular structures from scratch. So it's kind of toolkit for chemical informatics. So first of all, you have to have the required libraries that are Streamlit and RDKit. Code will be done in Python. So if you want to get both of these together, so you need to install, if you want to get it from pip, this is the place where you get all the information, or you can install the libraries for rdkit. Just pip install rdkit py and it would install. And with the help also, if you want to install Streamlit, that's the process. And to run a code in Streamlit will show, of course, when we see the code of this particular application that we are trying to build. It is Streamlit run, then the Python code, followed by the extension of the Python file. So let's just go back. Now we have done what we are needed to be done, like required libraries, we have gone through it. Now that to code. So first of all, what exactly we are doing? We are trying to create a molecular viewer structure for different kind of compounds, and for that we are doing some imports. So first is like we are importing Streamlit as ST, that is the Streamlit library to help build web application. Then to import this chemical informatics library, or the different kind of smile structures, we are importing um, RDKit. From RDKit we are getting in chem, imports the chem module from RDKit, which provides function to handle chemical information. From RDKit we are also using a draw particular function, which helps us to draw the molecules that we are trying to comprehend, or we are trying to build. Now to set up, we have given a title for it. It is as molecular structure viewer. You can change it to your liking if you want to edit. Now the user input. So we are putting in two different kind of smiles input. These are we can say hard coded to get started with, so that we get you acquainted with how the things work, so that next time you can also use a list of input strings and you can adjust accordingly. Very useful for people who are trying to create some kind of project related to bioinformatics, because it's a very new field that is gaining in popularity, and there are a lot of research work going on. So if you can create a project with bioinformatics, it becomes very useful to visualize this, and it is very appealing for people who are getting to see the output also. So we create first of all, when you are putting in the smile, it creates a text input field in the Streamlit app, where users can enter a smile string, pre-populates the field with a default smile. Similar with the second input too. Now what it is doing is that it is doing in the next step what is known as chemical information processing. The two molecules that we see, we are getting the molecular one, and we are converting it to a RDKit molecule object, so that we can draw it from smile strings. Then after that we are doing molecular visualization. So it sees that if both the molecules have been created, then it draws the molecule to a grid like structure, so, and populates to a particular value. You can change these values to your liking, so that the output that you get can change accordingly. We are also giving the column width to true, displays the grid image of the molecule on the Streamlit web page, adjusting the image to use the column and width of the molecule itself. So before going into the second application, we'll see it in action. This is the first code. First of all, as you can see, we have bought in the Streamlit library as ST, and then RDKit is being important. From RDKit we are getting in the chem, and finally we are using a draw structure for a draw molecule itself. Here we are taking in the input of the smiles, then molecule 1 and molecule 2. These are two different smiles we are passing in. So if both of the molecules are being converted, or say into the smiles formats to molecule objects, then we are drawing both of the molecule itself. So let's see this code in action. Now to run the application, we need to pass in Streamlit run, and as you see, the code name is st1.py. We are just passing in this st1.py, and whenever we are running this code, as it is as Streamlit is an front end for the code that you have built, it creates the entire application in a web-like interface. So let's see it in action. So now see, you you have created, or both of the molecules are being created accordingly as we passed in the pre-filled molecules. Now you might be asking that if I want to change the different molecules, or I can have a list of it, you can pass it directly from here. But if you want to create a list so that it is a drop down kind of application, we'll see in the next example how do you go about it. Now I'll stop this with Control C. I'm stopping the application. Let's go to our next example, that is example 2. Similarly, we bring in all the libraries, RDKit as well as Streamlit. Now set up the smile strings. A list of smile list is created containing a variety of smile strings, because we want to show how we can store it in a list like structure. The range from simple organic compounds like ethanol and acetic acid to more complex structures like purine. Okay. Now user interface, we have a select box, create a drop down menu for users to select a molecule string. There are two drop down molecules because we are showing examples for two different smile inputs. Index parameter determines which item in the drop down list is selected by default when the app loads. In this case, the first and the second items in the list are preloaded. That is, the examples that you choose in would be the first and the second one. Now chemical structure conversion. So it's a similar format, takes the smile input and it converts it into RDKit molecule object. These objects are then used to create visual representation of the molecules. Now visualization of the molecules, that is molecule 1 and molecule 2, both of them are created successfully. Then we will draw them. We use draw small molds to grid image application, generates an image showing both molecules side by side in a grid. The same sub-image size sets the molecular structure in SVG format, which is scalable and high quality. The st.image displays the generate image of the Streamlit page, scaling it to the full width of application. So let's just visualize or just go to the second application. As you can see in the st.2py, we have a list of smiles, and from the list itself we are putting in the index. As the index is 0 and 1, it takes the first and the second structure of the smiles that are provided in the list and it converts. But you have the option in the drop down so that you can choose from the options of list that are available. Similarly, with the help of smiles to molecule object, we are converting it. And finally, molecule 1 and molecule 2 is shown, and the image has been generated. Okay. So let's see like if we can change the parameters right away. I will just change it to 350 over here. Okay. Now I'll just save it right away, and accordingly I will just pass in the command, that is streamlit run st2.py is the file name. I will just stream in enter. And you see the structure has been created. Now if you want to go, a drop down list is there, select any compound, you will see both of them, change it to your liking. I can see the structures, again you change it, they change. And if you want to see the structures, these are shown in a different way. This is the structure of a different one. So that's the way you build the application, and this is a starting point for anyone who wants to start a very new project on bioinformatics where you can visualize the molecule. I think it is helpful for people who are getting started with. Definitely please go ahead and try it, and that would be it. Thank you, and the journey will continue.